Welcome. In this example, we'll take a look at a definite integral. This definite integral is an integral from 2 to 6 of 10x squared plus 7 divided by the square root of x dx. So one thing that we might want to remind ourselves of is the square root. This can be represented with a 1/2 power on our variable. So we could change that right away here. Just to visualize what this is x to the 1/2 power. And I can then think about rewriting this integral into two terms when I distribute and divide each of those numerator terms by x to the 1/2. So let's rewrite our integral from 2 to 6. The first term we can say is going to be 10. If I have x squared and divide by x to the 1/2, that will leave us x to the 3/2. If I do my subtraction of powers, plus I'll have 7, and if I have this, I can think about this divide by x to the 1/2 as the same thing as multiplying x to the negative 1/2 dx. So now that I have my variables with exponent powers here, I can now work with taking antiderivatives. So let's start with the antiderivative of our first term. This will be 10x, and we'll raise the power by 1, making it 5 over 2, and divide by the new power 5 over 2. Plus, we'll have 7x. If I add 1 to 1/2 or a negative 1/2, I'll have a positive 1/2 divided by a 1/2. And I'm going to hold off. I'm not going to write the plus c because I know I'm going to be evaluating here in my next step. So I have my antiderivative ready, and I'm going to want to evaluate this at the points 2 and 6. First, it might be helpful to reduce this down a little bit, clean it up. If I flip and multiply here, 2/5, I can say that this new constant, or the coefficient, 2 times 10 is 20, divided by 5 is going to give us 4. So we have 4, and I can rewrite this exponent now as x raised to the 5th power underneath a square root. So that would be the square root of x to the 5th. Plus, if I flip and multiply my 1/2, 2 over 1, I can say that this is going to be now 14 square root of x with that 1/2 power. And now we're going to be ready to evaluate this at 6 and 2. So let's just put these where they belong. We're going to evaluate at really f of 6 and then minus f of 2 per the fundamental theorem of calculus. Evaluate my antiderivative at b and at a. So the first one will have 4 times the square root of 6 raised to the 5th, plus we'll have 14 square root of 6. All of this we will subtract by 4 square root of now 2 raised to the 5th. And then we'll have plus 14 and then square root of 2. Now, we certainly could put this into a decimal, approximate this, but this is the solution for us. This is the exact solution. There's a few things you could reduce, but this should be an acceptable answer for this definite integral. So a couple things to review here. Remember, our square roots as exponent powers. And we'll notice that when we work with the antiderivative of fraction exponents, it works just the same. Just be careful about adding 1 to that exponent and dividing by that new exponent. So I hope this is helpful with this type of definite integral. Look forward to seeing you in the next video.